Hi, I'm Miss Sharon.
And my name is Dana.
We're engineers at GE Aviation. We were both Girl Scouts when we were young, and I've been a Girl Scout volunteer for 19 years, and Dana's been a Girl Scout volunteer for a while now too. As engineers, we're passionate about helping girls learn about math and science, engineering and technology, and the acronym for those subjects are STEM.
And right now, females are receiving over half of the bachelor degrees coming out of college, but a very small percentage of those females are actually going into fields that are computer science, engineering, or mathematics. So really, it's important for females to understand the types of things that they can do while studying STEM, as Sharon was talking about, and becoming involved in those types of fields, especially in the future as we start to have a lot more need for those types of professionals.
Because of our passion to get girls to realize that STEM is fun and rewarding, we're making this video. This video is a collaboration between the Girl Scouts of Western Ohio and GE Aviation. Dana and I are going to walk troop leaders, parents, and girls through the process of earning one of the new Girl Scouts of USA STEM badges, the Mechanical Engineering Badge. The girls will practice the tenets of the engineering design cycle to design a balloon-powered model car.
That sounds awesome. And to do this activity, you really don't need any crazy types of materials. You definitely need a balloon. You need 3 straws, and we'll go through what those will be helping for. 2 dowels or like barbecue skewers. You'll need string, tape, some types of materials to kind of attach the car and hold some things together. You need the body of the car. We recommend plastic bottle or a carton or even a paper towel tube, something you have laying around the house should work. And then for the wheels, there's a lot of different options there as well. You can actually buy some plastic wheels already for this type of thing. You can use lifesavers, any kind of round object. The most important thing is to let the girls be creative, have a couple options of materials that they can use to build their car, and let them problem solve as they go through it.
Let's start by learning some basics about cars and engineering. In a real car, the engine turns the axle, and the axle turns the wheels, and the wheels move the car. In our activity today, the balloon will act as the engine. If you'd like a little bit more detail on how the engine moves the axle, you can watch the 1-minute video, and the link is on the screen below us.
So before we get into actually building the car, we want to talk a little bit about what we call the engineering design cycle. This is important to think through a problem. So first, the engineers would think, what's my problem? What does my customer need? So for example, if you need to travel, you might start thinking about, okay, what type of vehicle do I need to travel? If you travel by water or land, that vehicle is going to be different. Let's pause the video right now to discuss what might make your needs different. So what did you think about? What types of things do you need to consider if you're traveling? Some things might be where you're traveling, what the weather is. If you're traveling by land or by sea, you might need a different type of vehicle. Also the terrain, if there's a lot of sand or maybe it's very mountainy, that's something you'll have to think about. So I'm sure you thought about a lot of other factors as well that can change the way that you would travel and what type of vehicle you might need. The same thing we're going to look at and think about when we build this car. So after the engineers define their need, the next thing they do is brainstorm ideas to meet that need. After brainstorming through some ideas, you can start to think about your design, drawing it out, kind of thinking about what the design should look like. In real life examples, we use a lot of real life modeling or computers to make models, 3D models, or even a real physical prototype of something, and that helps visualize and see what you're doing and if it's going to help solve the problem. So after the kind of design and drawing phase, you'll actually build and then test the design and think about what you could do to make it better. So this is pretty much the cycle that engineers go through whenever they need to solve a problem.
Yep. And so when you think about testing, I'll give you an example. At GE Aviation, our engines fly really high in the sky. And in the very early days of aviation, like 1918, 100 years ago, engineers were trying to figure out why engines seemed to produce less power at high altitude versus the ground. and they didn't want to send pilots in the air with engines that they weren't sure how they'd perform. So they took the aircraft engines on a big trailer to the top of Pikes Peak, which is a mountain that's 14,000 feet tall. Here's a picture. And right beside it is a picture from a modern aircraft engine test at high altitudes. We have a special airplane where one engine is replaced with a new test engine, and that way the pilots are safe, but we can still test the engine. In this picture, you can see the arrow pointed at the engine that is the one that's being tested. Next, the engines are evaluated and the engineers redesigned to fix any problems we found. We'll be doing this cycle until we have a design that meets the needs of the customer. So today, girls, you're going to use the engineering principles and going to use it when you're designing the balloon-powered model car. Dana and I are going to describe the steps in summary first, and then as you go through each step, we'll describe it in a bit more detail. And we'll tell you when to pause the recording so that you can do the activity yourself. And we'll tell you on how long to spend on each step before returning to watch the rest of the video. So the activity is intended to take about 75 minutes, starting right now.
All right, girls, so today you're going to apply the learnings that we'll go through with potential and kinetic energy and jet propulsion to design, test, and then analyze a balloon-powered car. If you'd like to see additional materials on balloon cars, we recommend watching this short video on PBS Kids. The link is shown on the screen. For today, you girls will follow a 5-step process. The first step is to learn about jet propulsion, potential, and kinetic energy, and apply these principles throughout the project. Step 2 is to design and build the balloon-powered car with those materials that we talked about earlier. Step 3 is to test the car, so you'll actually get to see it move. Step 4 is to analyze and understand and share the results of what happened when you tested the car. And then finally, the last step, step 5, is to brainstorm ways to improve your design. So let's get started.
Dana and I are working with a Girl Scout troop from Mason, Ohio, and they're going to demonstrate a lot of the activities and the discussions that you'll be having. But before we start with the troop from Mason, please pause the video and take 10 minutes to see if your group can answer these questions. It's okay to use Google if you need to. Then, listen to see the ideas of the group from Mason, Ohio. The answers given on the video are not a complete discussion, and you may think of many things that this group did not.
So today we're going to be using the design thinking process. So part of that process requires us to first define the problem, so that is to build the balloon-powered car. We're going to brainstorm some different ideas to solve that problem. We'll plan out how we're going to do it. We're going to build and test the car, and then my favorite, we're going to work on improving the car, right? So in order to build this balloon-powered car, it's important that we understand both potential and kinetic energy. It's also important that we understand how forces interact, right? So we have forces that'll be interacting with the car. And then because the air in the balloon's powering the car, it's important for us to understand how air moves and how air interacts inside the balloon, okay? So let's go ahead and get started.
All right, so I need 2 volunteers to help me experiment what is potential and kinetic. Kimber and Callie, let's go. So first things first, I need you to blow into the balloon and hold it. All right, hold it tight. Now, what's happening while you're blowing into the balloon? What was going on? All right.
Air was entering in.
Yes. Okay, can you feel on the balloon? Can you do a little, what does it feel like? Do you feel some force? Is it tight in there? All right. So now I need you guys to just let go of the balloon. All right, what happened?
The air went out of the balloon.
Yes, and that's totally correct because energy creates movement. So thank you guys for volunteering.
All right, so speaking of energy, who knows what potential energy is? Anyone want to take a guess? Yeah.
Stored up energy that's waiting to escape.
That is an awesome answer. Excellent job. So stored up energy that's waiting to escape. You can kind of think of it that it has the potential to do something, potential energy. It's what?
Impatient.
Impatient. You can think about that. It's getting ready. It's trying to get out, but it can't yet. What about kinetic energy? Who knows what that is? Yeah.
The air that comes out of the balloon.
So when the air came out of the balloon, it was moving. Yep, what else?
When the air was coming out of the balloon, it was being forced out, and the balloon was shrinking because there was nothing inside of it.
Perfect, yeah. As the air was coming out of the balloon was shrinking because the air was coming out. And kinetic energy is the actual movement. So potential energy is stored energy. It's stored in all of us and every object. It has the potential to move. Once it starts moving, that's when it becomes kinetic energy. So now our group from Mason, Ohio is going to brainstorm some designs for their car based on the materials that they have available. Listen to their discussion, then pause this video. We recommend you spend about 10 minutes or so writing down your own design. You can use the question on this slide to guide you. Don't worry, we'll show the slide again right as we ask you to pause the video so you can use it as reference.
All right, so to start today, we're gonna make a prototype of our car. Now, a prototype is a quick and easy way to actually see the product and to see how it's gonna work, but it's mostly to show others how it's gonna work. As engineers, we use prototypes to see the strengths and the weaknesses of our product and to see where we need to work on the most. It does not have to be perfect, but just enough to show. Now, in an example earlier, I had a balloon and then I just let it go. We're going to create a jet so that we can direct the balloon to go the exact way that we want it to go, correct? All right.
Who knows what a jet is? Any ideas? Yes.
It's a plane that goes really fast.
So a lot of times we do refer to airplanes as jets because they go fast. Yeah, what else?
It's like a smaller plane.
A small airplane. This is a lot of things that, yep, go ahead.
Like a turbo-boosted airplane.
A turbo-boosted airplane, that's a fancy word. So you guys are getting at the idea that a jet is really a fast stream of air or water through a small space. So the reason why we think of airplanes as jets is because they're using a lot of power and forcing a lot of power out through a small amount of space, causing them to move. And that's what we're gonna make today. So what I would like you guys to do, you should all have a straw, and then each group has a balloon. We're gonna make our jet today by attaching the balloon to the straw. This is going to direct the air coming out of the balloon and make sure your car goes straight. So if you guys wanna start assembling this, you should have tape on the end of the table there, and you can work together in groups to attach the balloon to the straw.
So one of the things that we think about as design engineers, we think about the materials that we have available to us. So we've already talked about our power source, right, or our jet. So what are some of the other things that we may need when you're building a car? What are some of the other things? Go right ahead.
You need wheels.
That's right, you need wheels. You need wheels, you need a body, and you also need an axle. Addie, what's an axle?
It's a bar which things rotate.
Very good, Addie, that's absolutely right. So now that we understand all of the materials that we have, all the parts that we need of our car, it's time to plan. So it's time to brainstorm and plan. So you have your paper and your pen, write down your ideas, maybe even sketch or draw what your plan is, okay?
Ladies, now comes the moment you've been waiting for. You get to build your car. First, you're going to insert 2 axles into the body of your car. Next, you'll make the wheels and attach them to the axles. Finally, you'll add your jet engine to the car, the balloon.
And adults, this is your chance to be available for the girls as they're working on their cars. Ask them some questions, start getting them to think about how they're going to build their car and solve some problems they might come across. Some things we recommend that you can ask: how could you connect the wheels to the body? How will you attach your jet to the car? But resist the temptation to tell them how to design or to solve the problems for them. Let them work through their issues on their own. While they're working, we do recommend that you start setting up the raceway. This is what the girls will be using when they test their car, and it's a little fun competition. So you can take a piece of tape, put it on the floor, and then another piece about 6 feet away, and this will be the raceway to test the cars.
Now it's time to pause this video and to take about 25 minutes to build your car. Be sure to use the notes that you wrote down when you were brainstorming your ideas. Have fun!
So use the materials that you have in front of you and the drawings and the ideas that you came up with and work in teams to start building your balloon-powered car. All right, ladies, show us the design of your car. Hold it up, let's see them. Wow, you guys came up with some good ideas. So over here, group number 1, what's one thing about your design?
We put the wheels close to the body.
Awesome. Okay, we'll see how that works when we test them out. What about this group?
We took a straw and we put it through a hole.
Very nice. So that's the jet that's going to power your car.
We like how far away the wheels are from our body. We used the scissors and sticked the stick in it and put wheels on it.
Nice. Yeah, so your wheels actually the axles go through the body of the car where those are on the bottom. So we'll see how they work out when we do the testing of the cars. All right, now your cars should be ready to test them out. First, you're going to want to blow up the balloon that's attached to your car, and this is you filling up the car's gas tank. Hold the end of the straw that's inserted into the balloon, hold the other end closed to keep the air inside while you get your car in position and set it on the ground. While you were building your cars, the adults were setting up the racetrack. So there should be a marking on the floor about 6 feet apart, and this is where you'll use to test your cars.
Now when the adult says go, let go of the straw and let your car race. The car that crosses the finish line first wins. Watch closely though as you let go of your car. What happens? Does it move forward? Does it go straight or off to the side? How fast is it? If you like, you can use a stopwatch or the stopwatch function on your phone to time the race. This adds to the data or information that you collect when you're testing your designs. We're showing you a worksheet on the screen right now. Please pause the video for 10 minutes to test and to write down your notes.
When I count to 3, you're going to let your balloon go and the cars are going to get started. 1, 2, 3. Excellent! Very good. So now, ladies, now that Sadie and Kaylee have won the first round, we're here for the second round. All right.
Wait, there's a third round.
So get your cars behind the start line. So before we go, there's one thing I want to ask you guys. Pay attention to what your cars are doing. Look for ways you may be able to improve, okay? So on the count of 3, I'm going to ask you to let your cars go. 1, 2, 3.
Yay!
Excellent job, ladies.
All right, girls, we hope you had a lot of fun testing your cars and also racing against each other. But now it's time to take a few minutes and think about what you saw. We're going to start thinking about and analyzing how the test went. How did your car perform? Similar to what Sharon had mentioned earlier, did it move like you thought it would? Did it go straight? How fast did it go? Did it move like you were expecting it to? If not, why?
So take 3 minutes to think and to jot down some notes, and then spend a few minutes with a partner and take turns sharing your findings. And make sure, it's really important, each of you needs to be sure to find at least one positive thing to say about your partner's car. And listen carefully to what your partner tells you about her car. Then you can offer ideas about why her car performed the way that it did. And when you're done talking with each other, write down those ideas about why you think your car performed the way that it did.
All right, girls, so now that you've discussed with your partner what you both observed when you tested your car, we get to think about how can we improve our design. So take about 10 minutes now to brainstorm ways that you can improve your car's design. We recommend you spend half that time, about 5 minutes, individually brainstorming some ideas, and then feel free to partner up with a different partner this time and talk about how you would improve your car designs. You might need some new materials, or you might think about changing something that you already have on your car. So think about some of the things that we talked about earlier: potential and kinetic energy, thrust, what a jet is, and how those might all impact your design. So you're using this time to really brainstorm how you can improve your car. Write down your ideas, discuss with your partner, and continue to think about how this will help your car's performance.
Now, adults, encourage the girls to revise their designs and to test their cars again when they get home. That's what engineers do. They design, they test, they improve, and they test again, over and over again, until they come up with a product that works the way they need it to. Now it's time to pause this video and use the worksheet on the screen to guide your thoughts.
So Emily, what's one way you think you may be able to improve your car that you would like to try?
To put the straw more straight than sideways.
Oh, well, that's a good idea, right? Put the jet more centered on the body. Very good idea. Dawson, what's one way you'd like to improve your car?
Using a different bottle, because like the bottle was touching the floor and the wheels weren't like moving.
I think we should tape the sticks under the water bottle so the water bottle does not drag on the table.
Those are some very good ideas, ladies. I love those ideas. And then Sadie and Kaylee, champions, what would you like to consider changing on your car to improve your car?
Well, we would consider taping down the straw so it wouldn't fall out at the end. Yeah.
Okay, good ideas. Thank you.
Dana and I hope you've enjoyed this activity and learned a lot. We even hope you'll be inspired to do more experiments. There are a lot of them out there on the internet, and there are lots more Girl Scout badges on STEM.
And if you have time, check out the videos on the GE Aviation YouTube site where you found this one. You'll see results from real engineers. Our GE Aviation engineers help people every day. The engines that we make power the Olympics. They can go out to remote parts of the world and help provide power to places that don't have it. The engines that go in our airplanes, those help people get to new places and take vacation or visit family. So here at GE Aviation, we're really helping to make the world a better place. So that's all for now. Thank you guys for watching.
Goodbye for now.